Hello class, and welcome back to the second video for chapter 10. I'm focusing mainly on 10.3, but I did pick a few problems from 10.1, 10.2. I'm only doing 3 examples, so it's pretty short. So if you still don't understand it, you still have the Tuesday and Wednesday when we get back from break to come and get some help. So by popular demand, we're going to do quite a bit of verifying identities, or you guys, we call it proofs. So what I want to do is show that the left-hand side equals the right-hand side. Feel free to pause and try it on your own, and then I'll be working it out too, so you can always play and make sure you got it right. So I'm going to take the left-hand side, and to square it out, no, I cannot distribute the square to a sum. I'm going to write it twice and then do FOIL. So that's what I'm doing here. And then FOIL it out. So I want to multiply the first times the first, the outside times the outside, inside times the inside, and last times last. And you get the little smiley face. That's just me being silly. Let me erase that. So remember, you should be taking good notes on this stuff. You're going to get credit for your notes. Okay, so the first times the first is sine squared x. The outside times the outside is plus sine x cosine x. This should kind of feel like chapter 8 right now. And the inside will also be sine x cosine x. Just putting it in the same order. Plus, the last times the last is cosine squared x. So I'm going to combine these are like terms, and then we'll see what else we have. So sine squared x plus 2 sine x cosine x plus cosine squared x. So I'm looking at the right-hand side, and I know I want a 1 in there. So I'm wondering how I can get a 1. Well, I'm recalling back to the last chapter when we had that. So we're just remembering at this time, sine squared theta plus cosine squared theta equals 1. So it doesn't matter what angle you have there. It's sine squared plus cosine squared is 1. So that's where we get our 1 from. Let me just draw a little thing. So 1 comes from the 2 circles, plus this guy here is, yes, you're right, the sine double angle. So I'm going to write sine 2x. And there it is, the right-hand side. So I'm going to put the little QED. So I hope that was just as easy for you as it was for me. Okay, hold on to your seats. Here's our second verifying of identities today. We did one of these similar in class on Tuesday, and we're going to do another one. So it's slightly different. So I want to, again, work on the left-hand side, but I'm kind of thinking about what tangent is. So here's my little thinking bubble. Tangent is sine over cosine. So if I can make the top of the fraction look like sine, I can get what I want on the top. And if I can make the bottom cosine, I have tangent. So that's what I'm going to do. I'm going to force the top to look like sine and force the bottom to look like cosine. So I'm going to pick the formula. So the double angle that I want is the one that only has a sine in it. So that's 1 minus 2 sine squared alpha. That's the one I'm going to pick because it's going to get rid of the cosine up top. Now, I did make a flashcard studying session for you on Quizlet, so you can visit that website. I have it posted to Skyward, and you can start studying your formulas because you have a little over a week to get to know them before you have a test. So this becomes 1 minus 2 sine squared x. I'll match up the angle over, and then the bottom I'm going to use the sine double angle formula, which is 2 sine x cosine x. Now we just got to clean it up. Now we're doing algebra. So the top, I'm going to distribute this negative to each term. So it'll become 1 minus 1 plus 2 sine squared x over 2 sine x cosine x. I'll work this way a little bit. The ones are going to cancel. And then I'll have 2 sine squared x over 2 sine x cosine x. So now you have the ability to cancel out one of the sines and cancel out the 2's. There you go. You have sine x left up top over cosine x, which we all know by this point is tangent x. Well, hopefully you know. If you don't, shame, shame, shame. You need to get to know that. There we go. We're all done. So last couple examples. So also something that you guys may be struggling with is finding exact values of weird angles without a calculator. So this one's a radian one, and I didn't do very many of these in class. So what I'm going to do is write out all the radian angles I know, because I don't know 7 pi over 12. The ones I do know are pi over 3, pi over 4, pi over 6, pi over 2, and if I had to go into the second quadrant, I would know 2 pi over 3, 3 pi over 4, and so on. So hopefully I don't have to go that far. I'm going to make them all have denominators of 12 because I'm looking for 7 pi over 12. So to make these have a denominator of 12, I'm going to multiply the top and bottom of the first one by 4, just making a common denominator. Multiply the top and bottom of the second one by 3. And I noticed already that these add to 7 pi over 12. So there's my angles. All I need to do is rewrite tangent of 7 pi over 12 as the sum of 4 pi over 12, which is pi over 3, plus pi over 4, which is the 3 pi over 12. And then I'm going to expand that out. So take a look here. We split up the angle 7 pi over 12 into pi over 3 plus pi over 4 angles we know. And now we're going to use the formula for tangent addition. I'm going to get rid of all this stuff now. So that's kind of what I do to get the radian ones. Okay, so it's not really letting me get rid of that, so I'm just going to probably end up using a new page. Just still testing out the software here. So here's the formula, expanded out. So it's tan alpha plus tan beta. So here's my alpha and my beta, over 1 minus tan alpha, which is tan pi over 3, times tan beta, which is tan pi over 4. So this is where I have to think of like tangent of 60. So I'm going to do a little work over here, a little thinking. So I'm going to draw a triangle. I know pi over 3 is 60. I'm going to label the sides, and then I know tangent of 60 is root 3. So it's root 3 plus tangent of 45, we know that one to be 1 pretty well, over 1 minus root 3 times 1, which is just 1 minus root 3. So this is where you want to get rid of the square root in the bottom, so you want to multiply by the conjugate of the bottom, which is 1 plus root 3. Whatever you do to the denominator, you got to do to the numerator. So we just got to do some algebra now. The top, I'm going to FOIL out. I'm going to do root 3 times 1. The outsides become just plus 3. The insides become plus 1. And the last become plus root 3. Over the bottom, which becomes 1 plus root 3 minus root 3 minus 3. So after this is all cleaned up, sort of running out of space, so I'm hoping you guys can figure out most of this, you're going to end up with negative 2 minus root 3 as your final answer. So see if you can simplify that fraction to go to that. Thank you for being so patient. So what I want you to do on this last thing is practice the last example that we just did. Find the exact value. Do not cheat, no calculator, because you won't have it on the test. And pause, and the answers are going to come back up on the screen. Here you go. You got your answers. Your first one, you're dealing with the cozy formula, and remember the signs change, and if you plug in the values, like find your cosine of 60 degrees, your cosine of 45, and so on, you should get root 2 minus root 6 over 4. All these answers sort of look alike, just like the tangent ones look alike. The next one, you got your favorite lunchtime snack, your sine sandwich, and your final answer comes out to be root 6 minus root 2 over 4. So I hope I was able to help you much more understand Chapter 10 today. Remember, I am available before and after school and also during tutorials most of the day. So on Tuesday, figure out if you need to come and get some extra help, because I hope everybody gets a great grade on Thursday's test. Thank you very much. Have a good night.